So I'm going to talk about the policy and current trend of the solar energy in Malaysia. So first we go through with the capacity growth and the target. Just focus on the NETR, Malaysia National Energy Transition Roadmap. So we target that at 2025 we want to have a 31% of power capacity from renewable energy, and 2035 40%, 2050 70%. I will explain all about the feed-in tariff, the large-scale solar net energy metering in the later slide. So look at the Malaysia energy sector overview, installed power capacity at 2022. So we can see that solar only contribute about 2% or maybe even less. But we compare to the renewable energy consumption by source, solar only contribute about 22%. So it's very less compared to the hydropower and other source. But with a combination of the everything like hydropower, solar and other renewable energy, only about 9%. But Nazmi said that Malaysia current renewable energy capacity level is at 25% at the 20 March of 2023. So actually what happened? So it's actually solar energy good, right? Is solar energy good? You see that solar is far below the global average when it comes to Malaysia. It's only like about 1.5% only. But remember, at the 5-year diversification policy at 2000 and National Renewable Energy Policy at 2010, we set the target that of a 20% renewable energy in the power generation mix by 2025. But in March 2023, Malaysia percentage of renewable energy was 25%. It's surpassing the 2010. How we make it? What we do it? The main reason for this success is actually to come with a solar energy. So solar energy is a key here. As of August of 2023, the NEM seems to generate about 850 megawatt of solar PV installed. So they also launched the large-scale solar program launched in 2017, encouraged a lot of local and international business to develop a big solar project which could generate and sell the electricity to wholesale buyers. So among 10 flagship projects identified under this NETR is the establishment of solar park. You know, solar park. And then this solar park also had a 5 sites across the country, which is consist of 100 megawatt large-scale solar installation co-developed by the Tenaga Nasional Berhad in partnership with different type of enterprise, cooperative, and state economic development. So let's see that. So after all the talking, okay, here's some a little less boring part, right? A lot of solar park. One of this Engi TTL Korean solar park PV park, we've generate about over 212 gigawatt per hour of power each year. So we have a LSS4 located in the Pulau Pinang with a total capacity of 336 megawatt. Expect to generate about 490,000 megawatt per hour electricity to offset the carbon dioxide emission a year. So we also have a Solar West, which is on 9 large-scale solar farm in the 3 different states, which are Pahang, Perak, Selangor, with a total capacity of 262 and 65 megawatt, mainly located in Perak. So for this Duratungga floating solar PV park, so is it the future? The project is construction is likely to commence in 2026 and we expect to enter into commercial operation in 2027. So let's see if the future. If it possible, the project floating solar will be the one of the biggest in the Asia Tenggara. But how? Because this is have a feed-in tariff. Yes, for the solar household, we can collaborate with the feed-in tariff. Feed-in tariff is a policy where the government guarantees a fixed payment for renewable energy producer like solar energy they generate and supply to the grid. The payment is typically higher than regular electricity price to encourage investment in renewable energy. So basically, it's just saying that with the solar panel, we could generate electricity in our home cell. Then we import the electricity from the grid when we need additional. And also we can export the electricity back to the grid when we don't use it. So we are paying a feed-in tariff. So we can use the electricity we generate so that we don't have to buy from a retailer. We have to buy from the TNB. So let's talk about what's the future of the grid energy in Malaysia. So first, at the very first, we have to say that the mainly renewable energy in Malaysia is coming from the hydropower. But we can see that solar PV has the highest potential, biggest potential here. If we include all the ground mounted rooftop and floating installation, it could raise to the highest number of 269 gigawatt compared to hydro, compared to bioenergy. geothermal combined. So solar PV definitely have the biggest potential, and I do see that it has a very bright future in the Malaysia.
Okay, so I will present about the challenges of photovoltaic. The adoption of solar photovoltaic technology in Malaysia presents significant opportunities for clean and sustainable energy production. However, despite its potential, various challenges hinder the widespread of implementation and integration in Malaysia. This challenge come from many factors like technicality and mostly from economy. So first challenges is weather variability. As we know, Malaysia have tropical climate that includes heavy cloud cover and monsoon season, which is will reduce the solar irradiance and limit the consistency of solar energy generation. For the second challenges is high initial investment. So for some Malaysian, although solar panel cost has decreased globally, still the upfront installation like equipment, batteries and inverter are still a financial hurdle for many Malaysians, particularly for household and small businesses. So for the third challenges is the public awareness. As we know, Malaysia government has initiated some initiative to spread awareness about the renewable energy like PV. So, but some Malaysians still have limited knowledge and awareness of solar PV system that make the Malaysian have perception that renewable energy require high investment cost, and they cannot see the long-term cost saving that will have if they install the solar PV. So last, for the challenges of solar PV is the affordability gap. As we know, solar PV adoption is still limited to only for higher income groups that will have higher investment for their PV. So leaving the lower income household behind the progress of installation of solar PV, and because of lack of supplier to install and maintain the solar PV system, the cost will increase significantly. That's all from me.
And today I'll be talking about the key issues facing the photovoltaic or PV sector in Malaysia. These challenges are grouped into three main areas, which is waste management, regulation, and also economic barriers. First, let's look at waste management. Solar panels typically last for 25 to 30 years. Many panels installed in the 2000 era are now nearing the end of their lifespan, and this creates a growing problem of solar panel waste. Without proper system for recycling or disposal, these PV panels may end up in landfills, causing the environmental harm. Unfortunately, Malaysia currently lacks adequate recycling facilities for PV panels, which recycling is complicated and expensive because PV panels contain multiple materials that require special processes to recover. Also, high transportation and collection costs further discouraging recycling efforts. Next is the issue of regulation. Malaysia's regulatory framework for solar PV system is still underdeveloped. There are no policies requiring for manufacturers to handle the disposal or recycling of all panels. This makes it difficult to establish a sustainable and circular solar economy. In addition, the development of formal guidelines is progressing very slowly. While temporary measures are being worked on by authorities like SEDA, delays in creating full policies make it harder to address solar waste effectively. Finally, we have economic challenges. One major issue is the high upfront cost of installing solar PV system. Even with government incentive, the initial investment remains a significant barrier for many businesses and households. And another problem is competition from fossil fuels. Fossil fuels are deeply embedded in Malaysia's energy market due to their low cost and high availability. This makes it difficult for renewable energy sources like solar to compete. In conclusion, Malaysia's PV sector faces serious challenges in waste management, regulation, and also economic factors. To unlock the full potential of solar energy and promote sustainable growth, This issue must be addressed.
Okay, next I will be talking about the advantages of solar PV system. There are many benefits to using solar energy, and in this video I will highlight some of the key advantages that are particularly relevant to Malaysia. By harnessing solar energy, we have the opportunity to shape a sustainable and energy independent future for our country. Let's go. Okay, let's begin with one of the most significant advantages of solar PV system. They are renewable and sustainable energy sources. Okay, unlike fossil fuels, which are finite and depleting, solar energy is abundant and limitless as long as the sun shines. For Malaysia, this is especially beneficial because our tropical climate provides an average of 4 to 6 peak sun hours daily. This ensures a consistent and efficient energy sources for years to come. Second, another critical advantages is the role of solar PV system in reducing carbon emissions. As we know, electricity generation from fossil fuels is a major contributor to greenhouse gases. Solar PV system, on the other hand, produce clean electricity without any emissions. By adopting solar energy, Malaysia can significantly lower its carbon footprint, aligning with global efforts like the Paris Agreement to combat climate change. Okay, next. Now, for number 3 is cost effectiveness. While the initial installation cost of solar PV system may seem high, the long-term saving they offer make them an excellent investment. Solar panels have minimal operational costs and provide free energy from the sun. In Malaysia, initiatives like the Net Energy Metering, which known as NEM, allow users to sell excess electricity back to the grid, further reducing the cost. Over time, this makes solar PV a financially sustainable choice for households and businesses alike. Okay, for number 4 is energy independence. Energy independence is another major advantage. Currently, Malaysia relies heavily on imported fossil fuels, which exposes us to price volatility and supply uncertainties. By investing in solar PV system, we can harness our local solar resources, reducing dependence on imports and strengthening our national energy security. This move ensures a more stable and resilient energy system for the future. Okay, last advantages is about the low maintenance requirement of solar PV system. Unlike other energy system, solar panel have no moving parts, which significantly reduce the risk of mechanical failure. With periodic cleaning and occasional inspection, they can operate efficiently for 20 to 25 years or more. This makes them a hassle-free and reliable energy solution for households and businesses alike.
Hello and hi everyone, I would like to explain today disadvantages of the solar PV. Okay, the first one is efficiency loss. Efficiency loss in solar photovoltaic PV system refers to the difference between the total energy available from sunlight and the small amount of electrical energy that solar panels and system can convert and deliver. The factors contributing to the efficiency loss is because of temperature effect, which is solar panels operate less efficient at high temperatures, and the second one is because of the shading. Partial shading from trees, buildings or debris like leaf can significantly reduce the output. Even if only one section of a panel is shaded, it can disproportionately affect the entire race performance, especially in systems not equipped with optimizer. The The second one is limited lifespan. The limited lifespan in solar photovoltaic PV system refers to the fact that solar panels and their associated components degrade over time, losing efficiency and requiring replacement or repair. Reason for limited lifespan is because of the material degradations. Over time, the encapsulant that protect the solar cells can discolor or crack, reducing light transmission and panel efficiency. And the second one is UV and weather exposure. Continuous exposure to UV radiation, temperature fluctuations, and moisture can degrade the materials of the panel, especially in extreme climates. The next one is the disadvantages are energy transmission losses. Energy transmission losses refers to the loss of electrical energy that occurs when electricity is transmitted from solar panels to the end user. These losses happen because some energy dissipates as heat due to the resistance in wires and other components in electrical system. Cause of energy transmission losses are because of resistance in wires, voltage drop, and distribution network losses. Transmission losses undermine the environmental benefits of solar energy by reducing the effective energy output and potentially increasing the reliance and backup sources like fossil fuels. Okay, and the last one is recycling disposal issues. Recycling and disposal issue of solar PV system arise from challenge of handling decommissioned panels and their associated components in an environmentally sustainable way. Solar panels are complex devices made of various materials including glass, silicones, metal, plastic and polymers and small amount of hazardous materials. Environmental risks could be gained for the landfill, like panels discarded in landfill can lead to hazardous substances like cadmium and lead into the environment, and carbon footprint, which is inefficient disposal or recycling negates some of the environmental benefits of the solar power.
Hello, my name is Kevin Homingka. I will present a statistic of solar energy capacity in Malaysia from 2014 to 2023 in megawatts. According to Sehata, Malaysia's solar energy capacity has increased dramatically during the last decade. Starting with a modest 205 megawatts in 2014, capacity has nearly tenfolded to 1,933 megawatts by 2023. This constant growing trends demonstrate the country's dedication to renewable energy adoption, which align with global sustainability goals. Further analysis revealed that growth accelerated significantly beginning in 2019. For instance, between 2018 and 2019, capacity increased by 64%, from 545 to 894 megawatts. This momentum continued throughout the pandemic years, with a particularly high increase in 2020, when the capacity reached 1,483 megawatts. By 2021, the capacity had increased to 1,787 megawatts, and Malaysia has continued to develop steadily, reaching 1,933 megawatts in 2022 and 2023. This figure reflects the increasing use of solar photovoltaic PV system, supported by government initiatives such as the Net Energy Metering Scheme and large-scale solar program. In conclusion, this rapid expansion of solar energy capacity put Malaysia as a significant player in Southeast Asia renewable energy landscape. Thank you very much.